Okay, with this question, the area of the shaded region is actually going to be if you find the area of this hexagon and then you minus the area of the circle. So for the area of the circle, it'll be pi r squared, and you know that because they're saying the diameter is 20, you know the radius is 10. So you've got that bit. So now we're going to look at the hexagon, like how do we find the area of this hexagon. So if I'm at the center of this shape, and they do tell you that it is a somewhere that it's a perfect hexagon, somewhere they would have told you it's a regular hexagon. Well, they're saying anyway it's regular because it's all got every side is 12. Okay, so if you can see, you can actually break up this hexagon into 6 equal triangles, so the triangles will all be exactly looking the same. So if you look here, you can get a full circle of 360 degrees, and so therefore if I divide 360 by 6, I get 60 degrees. So I know in here, this little triangle here has a degree of 60 there. Now I also know that the distance from here, say out to the edge, will be the same on both sides. So therefore I know, if anything, I know that this is an isosceles triangle because those two sides are the same. So when you have an isosceles triangle, what it means is these bottom two angles are also equal. So if you do 180 minus 60, you're left with 120, and then you divide by 2, you end up with 60. So now we know that these are 60 each. Now, if all the angles are 60, that means it's an equilateral triangle, which therefore means that these sides must be 12 because they're all the same. All right, so now we know that the triangle is the same. So let me pause. I'm just going to rub out a little bit. So what I've gathered now is that I've got this triangle, which I know is an equilateral, and all sides are 12 centimeters and all angles are 60 degrees. So if I find the area of one triangle and times it by 6, because we've got 6 of them, we'll know the area of this hexagon. So I've got 6 times this triangle where I've got 12, 12, 12, and 60. So you can choose which area of a triangle formula you want to use. You might use Heron's, where you use every side, or you might use the sine rule. So I'm just going to use the sine rule. So the sine rule would be half times 2 of the sides times sine 60 degrees. Okay, so we'll get that. Okay, so I get that one to be 62, it's set to the nearest square meter, so it's 62.3, so I'm just going to leave it square meters. Then I'm going to do the pi r squared, so I'm going to minus pi times 10 squared. Whoops, I didn't times this 62 by 6. There's 6 of these, so that's actually 372, sorry. And now I'm going to minus the pi r squared, which will be, and I'm just going to go to the nearest meter, so I'm not going to worry about decimal points, so I'm going to say minus 314. So if you do that, 372 minus 314, we get 58 meters squared, because we're talking about area. Okay.